In this video, I want to find the orthogonal projection of a vector onto another vector using the dot product. So here's what we're going to do. I have a vector A and I have a vector B, and I want to find this projection of B onto A, which is called the orthogonal projection of B onto A. And it's a vector in the direction of A such that this vector plus a vector that is orthogonal to A add up to B. So what is this vector right here? We're going to find it using the dot product. Here's how. So I'm going to start with A right there. This is A. And here is B. And what I want is a vector. This is 90 degrees right here. So if this angle right here is theta, then I know exactly what this length is. This length by trigonometry will be the length of B times the cosine of theta. But the length of B times the cosine of theta appears in the formula of the dot product. We know that the dot product of A and B is actually the number, the length of A times the length of B times the cosine of the angle between them. So this right here is actually the length of the projection of B onto A that I'm looking for. So I can solve for that and get that the projection of B onto A has length precisely given by the dot product. I'm solving for this, so dot product divided by the length of A. So here's my first formula, is that I have a formula for the length of the projection. But now I actually want a vector. I want the vector of that length and that direction. So I need a vector in the direction of A of exactly this length. Well, for that, I can figure out, first of all, a vector in here. So this vector right here is a vector in the direction of A of length 1. That is A divided by its own length is in the direction of A and length 1. So if I scale this vector by this quantity, then I get what I want. So the projection vector of B in the direction of A will be a vector in the direction of A divided by its length. So in the direction of A, but this is a unit vector, scale it to be of this length. So the scale factor is the dot product divided by the length of A. So now I can simplify this to be, this is the vector A times scalar multiplication of A dot product with B divided by the length of A squared. So this right here is a formula for the projection vector of B in the direction of A. As an example, let's find the projection of B onto A, of B in the direction of A. If you plot these vectors, this is the vector A, this is the vector B, so the projection, the orthogonal projection, will be somewhere here. So let's see what that is. As I just found out, the projection of B in the direction of A will be the dot product of A and B divided by the length of A squared times a scale A by that quantity. So let's see how much that is. The dot product of A and B is 0 plus 1 plus 0, so the dot product is 1. The length of A is the square root of 1 squared plus 1 squared, so the length is the square root of 2. I have to square that, and it has to be in the direction of 1, 1, 0. So the answer is that it is the vector, this is 1 over 2, so it's the vector a half, 0. So it is somewhere in here. So yeah, just like we had drawn it. So this is the orthogonal projection of B in the direction of A.